Hello and welcome to the start of the statistics modules for A-level maths. Now, the first video I'm going to do is all about the first part of this chunk of specification on the large data set. Now, because I teach Edexcel, I'm going to do Edexcel first. Now, Edexcel's large data set is all about weather. So remember, this is just for Edexcel. If you do AQA, you'll know it's about cars. OCR, don't know, because I don't really teach OCR, I really teach Edexcel. I used to teach AQA, but obviously we switched examples when they all changed in September 2017, about 4 or 5 years ago now. Anyway, Edexcel's large data set, what do we need to know? Well, one of these first things we need to know is the locations. Where are these weather stations? Where are these? So, locations. One of the first locations you'll see is in the UK, and there are 5 in the UK. We start with Lucas, that's how you pronounce it by the way, Lucas, not Luchas, or whatever you want to pronounce it, Lucas. We have Leeming, then we have Heathrow, which we should all know, is in London, and then we've got Herne, down south, and then we've also got Camborne down south as well. Right, so these are the 5 in the UK. We also have 3 overseas, i.e. not in the UK. For example, Jacksonville. Now Jacksonville, we know, is in Florida, so we can have a look at different types of weather that you might experience in Florida. There's also one in China, Beijing, or Peking as it used to be known as, and then we've got Perth, which obviously is in Australia. So we've got our 3 overseas weather stations. Now the one I want to make out here is Perth. Now Perth is in the southern hemisphere. What that means is we're going to have different times for when this happens. So for example, it is their winter during July to September. Okay, that's important. Now, between May and June, it seems pretty damn obvious, that's their end of spring for us here in the UK. We have that. We have July to September. Now, July to September, we have it is our summer. So I'm just going to put our summer down. Then we've got our October, which is the last month in the large data set. And that is the beginning of winter, so I'll put start of winter down here. So we can see these time differences. Now I've told you what the times are. So the time periods for when this data was taken, which is quite useful, is between May and October of 1987, important, and between May and October of 2015. Now the reasons why they were picked is this one was to do with the Great Storm. You'd be a bit too young to remember this, but the Great Storm of 1987 was, well, we'll expect more rain, things like that. So we can have a think about these things when we look at this. And then there's 2 more. There's the hurricanes. For example, we have Hurricane Floyd and Hurricane Joaquin. Really hard to say. Hurricane Joaquin. So we've got these 2 storms that are happening in the, well, 3 technically if you count the other one. We've got 3 happening during this time period, which is why this is happening. That's important. Right then, on to variables then, what we see in this large data set. Now variables are quite basic, I suppose. So we've got daily maximum temperature. Now daily maximum temperature, we're going to be measuring that in degrees centigrade. We don't measure it in anything else. Then we've got daily total rainfall, which in this case is measured in millimeters. So we have that to deal with. Then we've got daily total sunshine, i.e. daily total sun. Now daily total sun is just measured in hours, so That'll do for what we want. Then we've got daily maximum relative humidity. Quite a mouthful to say, but that is in a percentage, and it is mist/fog if that is greater than 95%. That's quite important. Daily mean wind speed is also on there. Now you might see that called as daily maximum gust, and that's measured in knots. Now, in questions I've seen in the past, it would want you to convert these into miles per hour and then convert to meters per second. Now, this is measured on the Beaufort Scale. Now, the Beaufort Scale I will put up here in a moment when we get to it, but the Beaufort Scale tells you how many values it can be, from having calm winds to having winds like a tornado or a hurricane, right? So we've got that going on here. So wind speed or maximum gust, either or for those. Now, we've got another one, we've got daily mean wind direction. Wind direction. Now this one is also called daily maximum gust direction, if you want to call it that. And they are on a bearing. So make sure you know how to do your bearings from pure maths. Then we got the funny one, which everyone likes, remember from 2018, if you've not done the exam paper. Well, the question was about octas in cloud cover. Now, some people put 1/8, 1/8, 1/8. That's wrong, it's 1 out of 9, because you can have a clear day as well as having 8 out of 8. So there's actually 9 segments. Remember that question. Then we've got visibility and pressure, these last two. Now, visibility is in decameters, or D subscript M. Decameters. Now, what's a decameter? Well, that's 10 meters. So 1 dm is 10 meters. So I can convert how we want. This one is in hectopascals. Now, hectopascals is equivalent to 100 pascals. So do any conversions you need to. Now I'm just going to switch pen, because we're at this halfway stage now. So the last few things really that come up are these odd things that you will see in the data set, which is nice to be aware of. You'll see things like NA, i.e. not applicable, so in this case the reading is not available. Or you'll see trace. Now trace is not to do with things like matrices, nothing to do with that. But this is to do with rainfall, and rainfall is to do with when it's less than 0.05 millimeters, and we usually take this as 0 in calculations. Okay. Then we're on to the Beaufort Scale, as I mentioned, the Beaufort Scale. What is the Beaufort Scale? Well, it is a discrete set of values, a discrete scale of 13 values. That's important. From 0, which means like it's calm, or I think it's like less than 1 knot, I think, if I remember it. So we've got that going on. Yeah, that's right. Hopefully you can still hear me. And then we go up to 12, including 0, of course, which is why it's 13 values. And that's when we've got a hurricane going on. So hurricanes means it's 64 knots or bigger. That's quite important. The Beaufort Scale is one of those where you kind of have to know about it, but then be able to use it in the same way. It's a bit weird. And then we've got our old favourite, our Cardinal Directions. This is things like northwest, north-northwest, and all that lot. So I pick my point, I can go up, I can go to the east, to the south, or the west, north, east, and south. Then I can have extra ones, i.e. northeast, southeast, southwest, and northwest. But then we can have other ones. So we can have these between these two, these between these two, these between these two, these between these two, and between these two. So we can have even more. For example, north, northeast, north, northwest. That one is going to be east, northeast, not northeast, east. We've got south, southeast, got east, southeast. We've got those two. Then we've got south, southwest, and then we've got west, southwest. Then we've got west, northwest, then north, northwest. All right. Last thing, octors. The last thing I want to mention is about Octoros. So that's 1/8 of the sky, measured in 1/8, covered by cloud. Okay. It's a discrete set of values as well, which is quite important. From 0, so a clear sky, to 8, which is completely overcast. Alright, and that is everything that you need for Edexcel's large dataset. Not too much to remember. You'd have to remember all these because you're not going to be given the large dataset in an exam situation. But I think we've covered everything on that list. So you really just need to be aware of this. So if there's a question in your exam about a particular day in Leeming or in Lucas, wherever, you should be able to apply this knowledge when we look at questions on the large data set.